All right, welcome back, everybody. This is the 11th annual, the 2025 Virtual Residency Workshop, and it is Tuesday, June 24th. This is our second session of the day. So I want to welcome all of you to um, how to do an intake interview. It's both a talk and a set of demonstrations, and our speaker is Dirk Colbury. So, Dirk, take it away.
Thank you, Henry. Hopefully everyone can see my screen. So today I'll be doing how to do intake interviews. This is actually from a curriculum called Cyber Ambassadors, which was developed, small plug, through a grant from the National Science Foundation. We've been teaming up with Henry since the very beginning, and Henry's been going a little longer than Cyber Ambassadors. And the whole idea behind Cyber Ambassadors was I was a member of Campus Champions back in 2009, but I also taught professional skills training in for Tau Beta Pi, which is the Engineering Honor Society. And Tau Beta Pi had a great curriculum. They called it Engineering Futures, but it was developed in the 80s and it was copyrighted in a weird way. So it was getting a little old and we couldn't extend the curriculum very easily due to the copyright. So we wrote the proposal to the NSF to say, hey, we want to build a new from scratch professional skills training on communication, teamwork, and leadership. And we want you to give us money. And we're going to partner with a bunch of organizations to do that. And specifically, we want to train CI professionals, cyber infrastructure professionals, on how to do communication, teamwork, and leadership. And NSF said, yay, we like that idea. And so they gave us some funding and we developed the curriculum. The curriculum consists of 9 modules. It's over 24 hours of actual materials. It's all free to use. If you're interested, come contact me. This week, we're going to cover just some pieces, not all of it, but little bits and pieces from the communications module, which is our first contact, let's talk, and it's complicated. We based all of the curriculum development in best practices in STEM education, science, technology, engineering, and math. There are lots of different correct ones. The one we picked says you learn best in a context. And so we try to establish the context to be in STEM, specifically in cyber infrastructure, but it can be extended into other fields because the skills we're learning are the same. The context is only helpful when you know who your audience is. To date, I just checked, we have conducted 18,000 participant trainings, including a lot of those that are coming from virtual residency. And we have 810 people that have gone through all 9 modules and participated in those. And then we've trained 148 volunteer facilitators that take our materials and go to other places and use them. So we're pretty proud of what we've done so far, and that's where we are. So that's my small plug. We won't do the plug again, but I need to make the plug. Today, I want to talk about what is an intake interview. And then, like Henry said, we're going to go through examples of intake interviews, and you're actually going to practice intake interviews. I think it's tomorrow. And so this is sort of the precursor to the precursor on how to do that. They'll give you more instructions about it tomorrow. Today, we're just going to learn some of the techniques that are involved. So first, an intake interview is that first meeting when you have with someone. When you don't know them, or you don't know, or they don't know you, or you don't know their problems. You might know someone from a friendly get together, but if you don't know what problems they're solving, and they're coming to you usually with a problem. And the whole point of an intake interview is you're there to help them figure out how to use the resources that you are in charge of to get the most out of their problem. During this session, I would like to use a mechanism called a chatter. So what I want everyone to do is to participate if you can, but have a low barrier to entry. And so if you have access to your chat window, I'd suggest you open it. And what I'll do is I'll ask you a question. And then I want you to type your answer in your chat window, but don't hit enter. And then I'll do a countdown. I'll do 3, 2, 1, chat. And then you hit enter. And everybody hit enters at the same time, and we get what we call a cheddar fall. It's like a waterfall of answers, and then you don't have to feel awkward about participating. You can just hit enter when everybody else does, and you're neither the first or the last. And also, if you don't participate, no one will notice, really. So hopefully that will help engage. I will read some of those, not all of them. If you get bored of listening to me, you can read a few other people's answers. So let's just do, for practice, let's do a quick chatter. Where in the world are you zooming from? Again, type that in, but wait until I tell you. So I'll give you a few seconds to type in, where in the world are you zooming from? All right, 3, 2, 1, enter. Oh, we got a lot of things. Philadelphia, Oklahoma, Columbia, Alabama, Denver, uh, Ann Arbor, Michigan. Hey, that's near me. Minnesota, Reno, Nevada. All right, so we're from all over. Atlanta. I didn't see any outside the U.S., but that doesn't mean they're not there. That's how the chatter works. I hope that makes sense. We're going to do a few of those. So be prepared. Participate as you feel engaged or want to. So let's talk a little bit about intake interview. And I'm just going to give a quick example. So here's something you might be. You never met this person, Lauren, before, and they come to you and they say, hi, my name is Lauren. I'd like to use the HBC for my academic work. How do I get started? This is a classic intake interview. We don't know anything about Lauren. We don't know anything except they have some sort of academic work and they want to know how to get started. And so I would like you to type, but not hit enter, a question that you might ask Lauren. It doesn't have to be the first question, but any question that you might ask Lauren to get more information. What types of questions would you be asking Lauren? And I'll give everybody a few moments to think about that. And I'm just filling the air a little bit. And then once we have a few minutes, we will share that with the room through the Chatterfall. All right, that should be enough time. 3, 2, 1, chat. Ooh, look at them all. What type of research do you do? What department are you in? That sounds great. Tell me a little bit more about your research and how you want to use the HBC. What type of data are you using? What is your timeline? Is this work for the university? Have you ever used HBC resources before? Would you mind a meeting? What type of data are you using? These are all great questions. What is your area of research? What sort of workload do you anticipate? Can you tell me more about your work? What is your familiarity with research computing? What code do you want to use? These are all excellent questions and absolutely appropriate for an intake interview. But let's talk about what our goal is. So our goal is in an intake interview, and I want to specifically specify an effective intake interview. So you could argue that our goal for an intake interview is to solve the problem. Whatever the problem the person coming to us has, we want to remove the barriers they have to the problem. We want to help them find a solution, and we want to implement a plan to that solution. That's usually what we're trying to do. Now, we might not be in charge of all of that. We might want to pass that off or something. But our goal is to help them solve their problem. But I would argue that an effective intake interview is more than just solving the problem. We also want to maintain the relationship. We want to build teamwork. We want to strengthen the connections with you and the person. And this will give us a foundation for future success. So I argue that an effective intake interview is more than just solving the problem, but it's also maintaining that relationship with, or building, or even starting that relationship with the person that came to you. And so all of the techniques we're going to talk about today are trying to do both of these, solve the problem and maintain that relationship. And like always, feel free to put comments in the chat. I am trying to monitor it. We can make this a little bit of a discussion. All right. So what is a good intake interview? Excuse me, sorry, for research facility. So you want to ask them questions. These are actually repeating what you all just said in your Chatterfall. Ask them questions about the research. What are they doing? What are their goals? When you can, avoid rushing, right? You want to make them feel like they're being heard. Ask them lots of in-depth questions. People love talking about their research, so let them talk about their research. Now, the one exception to avoiding rushing is tomorrow we're going to be under a bit of a time limit, so we might have to rush a little bit during the activity phase. But in general, you want to avoid rushing. Then you need to identify the fundamental problems. What is the core problem? Sometimes the person you're interviewing, the problem that they have might not be the problem that actually needs to be solved, or what they think the problem is not actually the problem. And I think a lot of us have experienced that. And then, since we're all talking about research facilitation, what are the problems in terms of computing? Um, and then we're looking to see how the problems would be solved and making sure that they have the skills that they need to solve the problem, right? If it takes programming, they need to have those programming skills. And then the key here is to identify what assumptions you might be having and what they might be having about you. And if you can identify those assumptions and actually verbalize them, that can really help the process, because there are assumptions, you just might not be aware of what they are. And a technique that I think Henry likes to say is try to explain it to me like I'm 12. That's a good technique. 12-year-olds, I have a 12-year-old right now. He's really smart. He just doesn't have a lot of life experience. So he doesn't know a lot of jargon and programming terms, or might have a lot of context for me to build analogies from. But that doesn't mean that he can't talk to me and understand what I'm talking about if I use the right, I use his level. He can actually think of very intelligent conversations. He just doesn't have the life experience necessary. So it's a good phrase, is we're not talking down to a person, we're just trying to meet them at a level that is accessible by most people. So next, I want to go through a few tools you can use when you're talking. These are actual tools you can think about using when you're having an intake interview. The first one is active listening. The idea with active listening is pay attention not only to the words, but if you can, the body language. Listen to what they're trying to say. Try not to always jump to solutions. You're trying to listen to what problems they're having. And pay particular attention to emotion. If there's frustration or worry, you want to make sure that you identify that and address that if you can, because that might block an actual solution to a problem. What you can often do is reflect back to the speaker with I statements. What I understood was, or what I heard was, like you're trying to connect back. You don't say you said or you are doing this, because that's a little bit argumentative and you're trying to build that connection. If you do find there are strong emotions, try to acknowledge it without judgment as best you can. Like, oh my gosh, that sounds really frustrating. That's much better than saying, calm down. That's completely out of proportion, right? There's nothing wrong with emotion. People can have emotion for a variety of reasons, but it's better to often to acknowledge that emotion without judgment than ignore that emotion or discount that emotion. The second tool is reduce jargon, right? Before you speak, think about what might be considered jargon. What is words in your disciplinary background? What are cultural language background of the user, right? You can have different cultures and there might be idioms that you have that don't fit with the person you're talking to. Also, their level of expertise. You have two choices when you have jargon. If you've identified that you're saying something jargonish, like I said, oh, we're going to get you a node. Well, a node is a computer. It's very jargony for HPC. You either need to explain what the jargon is, which you can do because jargon is actually quite useful. We invent jargon because it is a shortcut in communication, right? So if I'm in my research group, we use a lot of jargon within the group because I can say one word or one phrase to mean a lot of different things at once. And if the other person I'm talking to understands the jargon, a simple phrase can replace paragraphs and paragraphs of explanation. So we often invent jargon as a shortcut to communication. But when the person doesn't know the jargon, there's no shortcut. And then we have to do the explanation anyway. So you either need to explain it because it will be useful for the person to know that jargon, or just get rid of it. And those are your only two options. So that your first step is to figure out what you're saying is jargon. And then your second step is to think, can I explain it? Or do I need to explain it? Or can I just get rid of it? So I want you to think for a second, what are some examples of jargon that we use as research facilitators? think to your day, and again, we're going to do this as a chatterfall, so type something in. What are some examples of jargon we use as research facilitators? And we'll do that in 3, 2, 1, chat. Cores, GPUs, HPC, HPC, HTC. The box is hung. I'm going to kick it. That's a great one. Node, condo node, software modules, resources, RCD, Slurm, OpenSea, batch jobs, nodes, jobs, allocation. Those are all excellent examples. And some of them are actually quite useful. And again, your job is to decide what you can explain and what you can eliminate. And yes, absolutely, abbreviations or acronyms are all considered jargon. Okay, so our next tool I want to talk about is paraphrasing. So the idea behind paraphrasing is when you're trying to understand a complex problem, often our users, the person coming to us with their problem, will explain it using their jargon. And they haven't taken my workshop, so they have no idea that they're even using the jargon necessarily. And so our job is to try to figure out what they're saying and really dig into the problem. And so we can use paraphrasing. And so the idea behind paraphrasing is you repeat back what they said in your own words. And you pick out the pieces you understand. And if you didn't understand, discard it and just explain back what you did understand. This is not the same as parroting. So parroting is like a mirror, right? So you say something, or the person says something, and you repeat word for word back to what they said. That's not helpful because you might be repeating words that you didn't fully understand. Your job is to take what they said, try to understand pieces of it as much as you can, and then use your own words back to them about what the problem is. And then if you're correct in what you say, they can see what you understood, and they can either fix it or move on because you did understand what they said. So it's more of a lens that is being refracted in your brain about what you understood and how you're projecting that back to the user. So paraphrasing is an extremely powerful tool. So you're using active listening to listen to them, and then you're using paraphrasing to tell them what you understood, and it allows for a little bit of iteration. Sometimes you need to ask clarifying questions. This is different than paraphrasing. You're actually asking usually a short question to help get you a piece of context to understand where someone is going. So here's just a few examples that I use. What programming language does the software use? It might not be important, but sometimes just knowing the programming language can give you, as the research facilitator, a lot of context about what level the person is coming from, and give you a lot of that context that they might not be able to understand how to communicate to you directly. For example, another good just clarifying question, do you already have an account on our system? Yes or no can mean a lot of where you have to start in the problem-solving process. Have you ever used this approach before? If it's something they use commonly and they just need to go big, is very different than this is the very first time they used an approach. Right? And so clarifying questions can be really helpful. So I would like you to come up with another clarifying question, a small, short question that you could ask that give you a lot of context, right? So just type one of those up, and I'll give you a second to think about it. I'm going to slow down a bit. I'm going really fast for some reason today. So we'll do a chatterfall in 3, 2, 1, chat. All right, what kind of questions do we got here? Do you need to use a GPU? How large is the data set you're working with? Are you familiar with the command line? How did you do in your previous, how did you do it in your previous job, group or job? Are there others working on the project with you? That's a good context-based one. What are you unable to do on your current computer? Where is the data you are needing to use? Is this something that used to work, or is this something new you are trying? That's a good one too. I like all of these. Do you prefer command line or GUI? Do you have funding? I like that one too. Do you have an example of something similar? Explain to me your day-to-day work. Can you say it another way? Is the data sensitive? Actually, that's really important before we move on in a lot of my contexts. Do you have in-house code? Can you walk me through your workload? Is there a timeline? Those are all excellent questions. And again, the idea of a clarifying question is it won't give you the answer to it, but it allows you as the expert to sort of start to put the user in the right context. And these clarifying questions and having a few, next to you can be really helpful to say, to sort of figure out where you need to start and where you need to go with the user. Another technique that I got from Henry, I really like this quote. You don't ever have to say no. No is not building the relationship. Again, remember, you're trying to solve the problem and you're trying to build the relationship. But sometimes you can't solve the problem. But you can say no without actually saying no. You can say, you could try saying no because, but it's still saying no. You really want to say yes if. And this is a quote from Henry, who got it from Dan. I got this quote, Boatwright, and Henry doesn't know where he got it from. So I'm trying to give attribution here. But the idea is really good, right? You want to say yes if. Oh, we can do that, but you will need a lot more compute power, a lot more funding, or a lot more time, or whatever it might be. There's almost always a yes, but that if might be quite big. And the idea is, instead of just saying no, it's not possible, you say yes if, so that the other person can see what would need to happen to make it possible. Yes, if we have to have a fully working quantum computer, which might be a valid if, or something. So let's do, already did that. Oh, wait, I hit the wrong button. Often we get requests, at least in my high performance computing center, I'll get someone that comes to an intake interview and they'll say, I have a, let's do a quick example. There's the hard drive on my laptop is full. And officially speaking, that is outside the scope of what we debug in our HPC. But again, I don't just say no, go someplace else. If it's easy, maybe the hard drive, cleaning up the hard drive, there is something easy I could suggest. But maybe if it's a more in-depth problem, you don't say it's not my job. You want to build that relationship. Say, yes, that's something I don't do, but I know who does. And so I always maintain a list of people on campus who can help out. Or I would direct them to maybe a website or a tutorial if it's not something I can do directly. We call this a soft handoff. So find someone who can help, maybe even help them ask their questions to Google or ChatGPT, right? Don't just leave them in a lurch. The goal here is maybe you can't solve this current problem, but make them feel like it wasn't a waste of their time and help direct them to the solution so that they know they can come back to you in the future. Because solving the problem now and building those relationships will only come back to help you. All right. So after you've built that relationship and you've come up with a solution, you need a plan. And so always close an intake interview with action items. What are you going to do when and who's going to do it? So is the user going to follow up with you? Are you going to follow up with the user? At what time frame are you going to do that? Establish those before leaving. If you just say, hey, you're going to learn this, good luck, that's not really a great way. You want to say, hey, you're going to learn this. I'll follow up with you in a week. Or you follow up with me in a week. And then put that in your calendar or your to-do list or however you action it and actually follow up. That's a good way to build a relationship. People can go off and do their own thing. And then you just follow up and you say, hey, were you able to get that working? If not, is there something else we can do to help? Building relationships come back to you in an exponential fold. So yes, you want to be able to solve the problem, but sometimes you can't. Always try to build that relationship. So next is the fun part. We are going to do some fake examples. So I want to, again, make sure your chat window is open. And what we're going to do is a fake example. These will be videos. And I want you to live chat your thoughts. And the idea here is when you see something that's wrong in the video, chat about it. If you see something you like in the video, chat about it. These videos are scripted, sort of, but they're purposely, you're not going to offend the two people that are in them. We did this on purpose to create a artificial intake interview, and they are fake. Any questions you have for us, please write those down. The idea here is to have a conversation, but there's a lot of us in the room. Actually, how many of us are in there? There are over 130 of us in the room right now. So don't be afraid to put things in the chat, and I'll try to get to as many of them as I can, and we'll have a discussion after the video. So just a streaming sense of consciousness of the group. I hope y'all that makes sense. And then I would like to put the caveat here. The story names, characters, and incidents portrayed in these video productions are fictitious. Any relation to real-world people and event is entirely coincidence, and the names are changed to protect the guilty. So actually, I love the comment. I'm gonna actually address one comment. David said, "My problem with building relationships that I have 300 research groups, every one of which would love to use me as their postdoc or staff researcher. We have to draw the line so that we provide the what is up to them." Absolutely, you don't have to say no, and you can still say no and draw lines. I do not code for other people. I will give people of my time. I don't mind giving people an hour. I usually, that's the max I'll give to any one project, maybe two if it's interesting or related to my research. But that doesn't mean I'm saying no. I'm still building those relationships. I'm just guiding them to where they need to be. Sometimes they might want something that I can't give. That's fine. That doesn't mean I have to break the relationship down. I can still say, yeah, that's something that sounds like it's a really useful thing. Unfortunately, I'm not the right person for it. Have you considered and consider other options? Honestly, everybody has a price. I'm kind of expensive, but I do at the university have a consulting rate. And if they wanted to pay for me to consult, and it's a project I'm interested in, they can. But you know, our HBC has that possibility. But that doesn't have to be that way. And then there are other ways to get help. And knowing what those are as a research facilitator can be really useful. For example, we have some computer science capstone classes, and they're always looking for projects. And sometimes when I've been in a intake interview with a faculty, I realize that their project could be done by a team of undergraduates. And so I know who the undergraduate capstone coordinator is. And I've put those researchers in contact. Now, that has nothing really to do with me. All I did was a soft handoff. And those are types of resources that if you know. So let's get to the video because it's fun. This one's called the Sandboard Strata Method. So stream a thought in the chat. Let's see if hopefully that's.
Hello, thank you for taking time out of your schedule to meet with me. I really appreciate your help. My name is Dana, and you are?
My name is Jesse. Hi, Dana. Thanks for reaching out.
Nice to meet you, Jesse.
Yeah.
Okay, I'm very frustrated. I have a lot of data I need to process using the Sandboard Strata method, which is better than the more common FCFD method. However, my transient error is much larger than my latent error. I think I can reduce the transient error, but I need to increase the Calhoun threshold. But then the software doesn't run on my computer. So I need to make it run on the supercomputer. I was told you were the person to talk to.
Oh, Dana, I'm sorry to hear that. It sounds like you've got a cascading problems here. You know, what is your timeline right now? Are you like, do you need, you know, how are things working out for you right now?
I mean, really, we've got a paper we're writing. We can't get the results that we need. I would like to submit that paper in a couple months. I have a grad student who's starting this process, but we just can't even get the software to run because the computers are too slow.
Well, we need to get you back on track. You know, my job here in research cyber infrastructure is to, try to solve or figure out where your problems reside and see if we can't bring some clarity to work through these problems. You threw a lot at me in that call. What specifically can you describe the systems that are running these calculations right now for me again?
Oh, it's my this computer I'm talking to you on. It's my Windows machine.
Okay, so you're working off of a laptop. Are you connecting to a larger compute node, or are you just
No, this is a desktop. It was pretty powerful. I bought it a few years ago, but I had my graduate student pick it out for us. It has lots of memory and lots of cores. It's about 4 years old.
Okay.
It was top of the line then. It cost us something like $10,000. I can't give you the specs, my grad student could, but it was an expensive computer. And it so far has been doing amazing work. It's just when we increase that tell home threshold, it just grinds everything to a halt and nothing works anymore. And the math doesn't get going. And we just need the supercomputer. All I really need is to just take our software and run it on the supercomputer. Because I just needed to go faster.
So who's responsible for writing that code? Is that the work that you're doing, or is that your grad student?
Well, I mean, these are all standard methods. So my grad student typed them up in MATLAB.
Okay.
And then we run MATLAB on this computer. Like I said, they're pretty standard methods. We're not doing anything crazy outside of my field. But it's well known that as you crank up that tell home threshold, computation just grinds to a halt. And so
I see.
We have been leading the pack in our research area, mostly because of this desktop that has been powerful enough. But then I was told that the supercomputer's on campus, and so we just need to use the bigger computer.
You need to move to the bigger computer. Now, can you think back to what the last time you were able to successfully run this code?
Oh, I mean, I can run it now at a lower tell home threshold.
I see.
But once you creep it up past 0.7 or 0.8, you're done.
I see. And are you using your parallel computing? Have you explored any of that work?
Well, I do know this computer has, I think, 16 or 20 cores. I can't remember what they bought. So that they told me that makes it run faster.
I see. Okay. Well, it sounds like what we need to do then, if you're noticing that threshold change is what's locking out your code. So we need to get you in front of a resource to sit down and review that code to see if there's a way that we can get it to better utilize the processors that you have.
Okay.
And
why not use the supercomputer?
I think that what we're going to find is the supercomputer is going to provide you the same results.
But why wouldn't the bigger computer run faster?
Well, we don't know that for sure yet. And I think that if you're telling me that the threshold, as you edit that threshold, I think what we may have to, sounds like you've got quite a few resources on that machine already. And my sense is we might be able to get a resource in there to help you optimize that code. And then we can see about how to transfer that to the supercomputer would be one option. I think what we want to do is look at your code locally and see if we can isolate a problem there first before we introduce an entire new environment. Then we will lose understanding of control over additional variables if we just move right to the supercomputer. I think the best approach would be to work with the resources you have and the team that you have currently.
So I have 20 cores on my computer, and I was told that the supercomputer has 10,000 cores. It seems to me that I should be able to do a problem 1,000 times bigger on the bigger computer.
Yeah, that makes complete sense to me, Dana. I think that we should, I just don't know the answer to that. And I think we need to start first with your resources and with your students and take a look at that code. And let's get a person in to give you another set of eyes on that code and see if indeed we can't add just a little more resources or add up that calculation a little bit more and see if we can get that running again on your machine, and then reach out to the supercomputer to see if indeed we can take that code and move it to the supercomputer. But first, let's look at your existing resources before we jump.
Oh, you're the expert. Thank you for helping me with this.
Not a problem. I enjoy this. Thank you very much for reaching out, and let's get another call scheduled.
Perfect.
Great.
Okay. Oh, wait. Am I muted? No, I'm not. All right. So I think that's a fun example. I got to pretend to be the user, and I had a lot of fun working with Justin Booth, who's a friend of mine who works here at MSU with me. And we had a fun making this. Also, if you're curious about the Strata Sanborn method, yeah, we made all those words up. I just made up something, and it was super fun. It was like writing for Star Trek or something, just making up words that sounded right. So some of the things you said, lots of words from the researcher at once, right? The researcher just threw out a ton of jargon. I knew it was jargon because I made it up, and it doesn't actually have any real meaning. But this happens all the time. When you're facilitating, we can't be experts at all the different disciplines, but that doesn't mean we can't help. And so your job is to get around the jargon as best you can. And Justin did a great job with that. Or I'm sorry, his name was, I forgot what the character names were. But yeah, that's the idea. And there was a lot of information up front. And the facilitator's job was to sit back and try to identify it. And I think this was a pretty okay, reasonable plan for the problem, to solve this problem. Was it the only solution? No, there were lots of other solutions to this problem that they could have considered. But every research facilitator are going to see the problem slightly differently. Maybe you are keying into the fact that it's MATLAB, and maybe MATLAB, you consider it to be a slower language, or maybe even though you have 20 cores on your computer, are you actually using all 20 cores, which I think was the research facilitator's thought here is, wasn't clear that all 20 cores were being used, or if they were being used, were they being used effectively, which is not a bad thing to start. Now, not all HPC institutions have the flexibility to debug over the shoulder with a researcher on their personal computer. There are lots of reasons why that might not work. We here at my university do that all the time. So we'll often help the researcher on their own computer look at their research workflows. But that's something we have the flexibility to do and is part of our mission. Not all HPC centers have that flexibility, and your mileage may vary. Yeah, one comment said researcher may not be using parallelization. I think that's a good observation. Also, when you're increasing things, any threshold or any limit on an algorithm, we don't know what rate that algorithm scales. Is it a linear scaling algorithm? Is it exponential? Is it higher than that? And that's maybe not a question you would ask the researcher, but you do need to know. It might be that raising it above a certain threshold, no computer in the world can solve that problem. And that would be something important to look into. I like that. Safe levels of patience. Yep, the researcher did a good job of making sure that they understood what the facilitator did a good job making sure that the researcher understanding what the researcher was doing instead of just going bigger is better. We all know, and maybe some of us, bigger is not always better. I mean, the nodes, the computers on our HPC, a lot of them are only 20 cores with 128 gigs of RAM or something like that. That's great, but if that's what you have on your desktop, running it on the HPC won't speed it up, especially if it does shared memory parallelization. If you need it to run faster, you might have to go to shared network parallelization, like across between computers on the HPC, and that's really kind of complex, or maybe might be complex. And knowing all that is actually hard. Let's see, do we have any negatives up here? There were definitely negatives. think I saw one, but I can't find it now. Well, someone said, I can't find it, that there, at one point, the research research facilitator said you instead of I. They said you threw a lot at me. And I agree. I would have, you're not correct all the time, but an I phrase would have been better. You could have said, wow, that's a lot for me. Or me and I are the same idea, right? So you say, wow, that's a lot for me. I'm not sure I followed it all. And then you can say, you can come back with it. Instead of saying you, which is a little bit argumentative, you could say I or me. And that's a little bit more useful. All right. Anybody else want to say anything, or did I miss one? Feel free to put it in chat. Otherwise, we can move on. All right. We're doing great on time, so let's go to the next one. Oh, look, I had questions. All right, we can skip those. All right, so now this is a different problem. I think in this one, I'm playing the research facilitator, and Justin is playing the researcher. So there's a context switch here because we mixed it up a little bit. So this is me. Oh, that's a good comment, Melissa. Deferring to a grad student might imply that the researcher doesn't know the research, which is often true, but you might not want to imply it. Often faculty are at a higher level of thinking about their research, and they don't often get into the weeds. It varies by discipline. I mean, even in my own research, I consider myself a pretty good programmer, but I have my own research group, and I don't know what my students are doing at the low level necessary. I can usually help them, but I have to do these types of interviews with my own students because I'm not always keeping track. And I might, if someone else asks me what they're doing, I might say something wrong because I don't always know what they're doing. All right, let's do this one.
Hey, my name's Jasper. I work here at our local high performance computing center. How can I help you today?
Hey, Jasper. My name is Jamie, and I am in need of some desperate help right now. I am a faculty member in the remote sensing department, and I am working through a whole bunch of imagery. And what I'm trying to do is some experimental analysis, and we've got a whole bunch of imagery. We're talking about 10,000 images inputs right now that we need to do processing on. And we had this working, and we had our algorithm set up, and we were processing this data just fine. And now we've upped the ante, and we have more inputs now that we need to put in there. And things are just slowing way down, and I need some help and to figure out how we can keep moving forward. And I'm feeling like the supercomputer might be my answer.
So can you tell me more about your analysis? I mean, how long does it take to currently process your images, and on what kind of computer are you running on?
You know, we're running on the state-of-the-art Windows machine. We've added as much RAM as we can to the machine. We've got the video cards. We have cooling systems in there. We're ready to go. The second, you know, it's about 10 minutes per image that it has to go through pixel by pixel and to do comparisons and analysis. And we are, we've never used a supercomputer before, but we just know it's got to be the answer to our problem.
So when I hear image data, one thing that comes to mind is the results of one image dependent on the results of another image? Are they independent results? Does that make sense to you? So does it matter which order I process the images in?
You know, it doesn't. It doesn't matter. We've got a set of algorithms on each that are looking for they're looking at the patterns in each image, and they're off-putting data into the statistics that we are valuable metadata for each image.
No, that's good. So if it was like a video where, one frame depended on a previous frame, it gets harder. But with independent analyses, that means we can run them on separate computers at the same time. And we call that parallel processing. So,
Okay.
so if you're saying it takes 10 minutes to run a single image, if I do that calculation, which I did on my little Google calculator here,
Fancy.
it will 10,000 images will take approximately 65 days to run the way you have it written.
Yeah.
Now, that's where your slowness has come. Now, there's lots of options that we could consider. One is there anything we can do to optimize the code? It sounds like you got a very good desktop computer with a lot of resources, and you're probably not utilizing all those resources effectively. So we could look at the code and try to optimize it. That could be one thing to do. But since it's giving you analyses that you want, the other thing to do is we might be able to port it to the high performance computing center. And our system, you know, a standard allocation can run on 500 computers. And so now your 10 minutes per image of 10,000 image divided by 500 computers means we could run it in about 3.5 hours.
Oh, that would be fantastic.
What I like about that is that doesn't break your current code, right? If it works on your computer. Now, I don't know if it will port over. You said you're running on Windows.
Yeah.
Our HPC runs on Linux. So we'll have to look in that. There's also a possibility that there's some efficiencies in the code that we could add that might solve all of our problems, and you can continue to use yours. But these are the types of things I want to look at with you.
Okay.
And so, yes, we can do that. Does that seem like a reasonable
But Jasper,
solution?
that sounds expensive. You know, is this something that you have resources that can help me with this?
So
you know, I've only got a few $1,000s left in my grant.
So that's very wise. So right now, the HPC on our campus is free for all researchers.
Okay.
But up to a limit. There are also national resources that are free through the National Science Foundation called Exceed resources. We can get you on those if we need to. There are lots of free resources. Some of them require, like the Exceed requires you to write a short proposal, that kind of thing. But they're very large resources, and we might be able to do that. So
well, it was my grad student that wrote the code, so that's, you know, that he's off on an internship. That's not. Can you guys help me with that code?
Well, we don't have coders in our lab, but I would be happy to spend a few minutes looking through it with you, because my expertise is coding. I will not be rewriting it for you, but I should be able to identify if there is some obvious problems with the code or obvious speed ups that we can make.
Okay.
And I'll do that for anybody on campus, right? Give me about an hour with you in the room, and we'll look at the code together, and I'll see if I can see anything obvious. If not, we can still run on the HPC. Even if it's non-optimal, we can get it down to 3 hours instead of, 65 days.
Yeah, that would be a great start for us. Thank you, Jasper.
Yeah, happy to help you, Jesse. And I hope to see you soon. Let's reschedule a meeting quickly and have you, let's look at your code.
Great, thank you.
All right, so that was just a different one. And so let's go through your questions here. All right, now I scroll back though, and I can't tell where the new comments start, so I'll just scroll up. So I think I said Jesse, and the person was Jamie. Who's going to do the porting? Who's the trading? What is the timeline? Those questions did not get answered. That's a good point. The CI is knowledgeable and access resources. Excellent. Never promised that much speed up. So 500 is a lot. If it's truly pleasantly parallel, that might be possible. But yeah, you don't want to overpromise if you can avoid it. That's a good feedback. State of the art could mean anything. That's a true statement. State of the art 3 years ago is not state of the art today. All right, these are great. Very optimistic person, assume code is serviceable. I happen to know that research facilitator was emulating me a little bit. My research is in high throughput image analysis, so I probably was well suited for that particular problem, which is why we used it as an example. But yeah, that's a good example. Let's just do this again. The exact same scenario, but slightly different. All right, so I want you to do the same scenario. Oh, wait, let me make sure I asked all these questions. Did Jasper consistently understand the research? Did Jasper solve the problem? I'm not sure Jasper solved the problem. Jasper had a plan for moving forward. Um, did they maintain the relationship? I think there was a pretty good rapport between the two. All right. Let's do take two. They really like it? There we go.
Welcome to my office hours. How can I help you today?
Hi, my name is Jamie, and I am a faculty member in the remote sensing department, and I could really use some help. I'm running some compute on some satellite imagery, and it's just not working out for me. My resources are locking up, and I need to talk through a way to move this to the supercomputer.
Okay, can you tell me a little bit more about what kind of calculation you're doing?
Yeah, I've got thousands of satellite imagery. I'm doing comparisons of their pixel values. We're doing some nearest neighbor calculations. We're looking at all of this data, and we're trying to seek out some reflectance values that will help us with some climate change data that we're deriving from this. And we're just getting more and more data, and it's just getting more and more complicated. I have a state-of-the-art machine in my office with some GPUs and some great cores that are helping us get this work calculated. And the more data we add, the more cumbersome it gets.
So why do you think moving the supercomputer is going to help you?
Because it's super, right? It's got more.
It is.
It has, you guys, there's more resources, and it just felt like I needed to throw more resources at this algorithm to make it push through. And we're getting more, we're getting some great feedback in our analysis approach, and so I'm expecting thousands of more imagery that we'll be able to put into this process. And so our initial white papers on this are getting some good feedback, and we're ready to start to expand this. And the more I expand it locally on our machine, the more trouble I get with the compute time.
Excellent. So all you need to do is fill out our form to get an account, and then you can use standard SCP to upload whatever code and files you need to the computer. And then we'll have you write a Slurm script, and you can submit a job, and you'll be up and running in no time.
My graduate students are in the field for the summer. That's not, so being able just to hand off the, upload code is not going to work for me.
So what do you need? I mean, it's pretty straightforward stuff.
Well, it doesn't sound like it. It sounds like you're asking me to do all the work here. Are you, what's SAP? What's do you need an account number? Is there a cost associated with this work?
So using our local HPC is free, but you have to use it. It's a supercomputer. It's not, it's not an average person computer.
Okay.
You need to use, you need to get an account. You need to log in. It's all free. We have a wiki, and we have a bunch of videos on how to use the system. Just watch those videos. You'll get on, and you should be, it sounds like your system should be pretty easy. And if you, have problems, you can submit a ticket to our ticketing system.
Okay. So this is a free resource, and, I've been doing a lot of research, and I have a lot of, indirect costs come from my grants that I thought helped pay for these types of resources. And now you're telling me to just get in line and fill out a ticket? Is that what we're doing here?
Yeah. So it's all free. Okay. We just provide, you log in. We have a pretty standard interface. And if you're not familiar with it, you could come to one of our tutorials, which are fairly regular. And if not, we have some online tutorial help. I mean, it is a supercomputer. It is not easy, but it's pretty straightforward. If you're running it on your local computer, a savvy programmer should be able to have no problem porting it to the HPC.
Okay. All right. Well, I have some collaborators at other universities that, have some resources. So maybe I'll work with them to look for another solution to this problem.
Oh, that sounds like a great idea.
Okay. Well, thanks for your time, I guess.
All right, you take care.
Bye.
So that one was more for me to have fun and have a smarmy looking mustache on. Not that all smart mustaches are smarmy, but I think I look in this particular mustache particularly uh, smarmy. And I was appreciating your comments. I think most of the feedback was that it wasn't that helpful, right? They were dismissive. I was dismissive. It wasn't me though. I was pretending. Um, they were they didn't feel like they were trying to listen to understand. They were trying to just point them to the documentation and the videos and just let them process through that, right? And it just wasn't super helpful. We have a few. Yeah, and if your goal is to maintain the relationship, I think most of the consensus here is the relationship's not maintained. However, I want to stress some of us have, if we're not thinking, might have said similar things, right? What seems easy to us might not be easy to the researcher. And obviously, we're acting here to overemphasize, right? We're leaning into the relationship and the bad things. But you can imagine saying a lot of these things in a much more polite context, but they're still not useful, right? Oh, wait, someone said, honestly, I'm on the side of the IT guy in that one. I wonder what was that one? Anybody who, I wonder what they were referring to with that comment. If you were that and you want to
I
mention
could
it,
speak to that. I mean,
yeah, go for it.
it was somewhat in jest, but I mean, I can certainly understand the concerns that were being presented there. I mean, I obviously don't know how research computing is handled at a lot of other institutions. Ours doesn't do a whole lot of it. But I mean, if your job isn't dedicated to just supporting faculty researchers, I mean, it's a completely unreasonable ask for the faculty member to essentially want them to do all the work that their grad students would be doing to get their stuff working in the environment. And if you've got a lot of
Absolutely.
responsibilities on your plate, you can't just suddenly drop everything to give one-on-one research support to a single faculty member.
Yeah, expectations have to be aligned, right? And so what are you expecting to provide versus what is the researcher expecting to receive? And those expectations might not be aligned, and you might have to say that they're not aligned. But you can often say that without just saying no. Like I've said, you can often say, well, that's not what I do, but maybe I can direct you in the right way. Maybe I can help you in some other way. And agreeing to help does not mean that you have to do work. It's just saying, maybe I can help point you in the right direction.
Yes, certainly it could have been stated in a more diplomatic fashion.
Right. Right. And the idea here is, can you state it in a way that you can say no without saying no? Say, unfortunately, we don't have the resources to help everybody out. However, maybe we can point you at some of those resources, or maybe we can point your graduate students to a course or something like that. So aligning expectations is a big part. I probably should make a slide for that. Aligning expectations is a big part because sometimes the expectations line up. What you can provide is what the person needs, but oftentimes those expectations don't line up and they don't understand what you can and can't provide. And so being able to explain those and understanding where they're coming from is really helpful. Ooh, I got more comments I'm going to read. Yeah, faculty don't often know where indirect costs go. It's sort of a magical thing. That's a good comment. All right, I think I had a few more questions. Let's go through them. First of all, I am goofing around in this scenario. And you can put this in chat or just say it out loud. I don't care. But was this realistic? I mean, is the scenario of 10,000 GSI images realistic? So yeah, I think it's incredibly realistic. I actually am working with a student. I made this scenario before I'm working with the student, but I'm currently working with a student. I literally had a meeting with them this morning about their GIS data and just the sheer amounts of uh, gigabytes of data they need. The analysis is pleasantly parallel, but to download the data they need to do the analysis is actually quite expensive. The region they want to do of the satellite data is the entire US. And they calculated it, and it was something, on the order of, and I forget what the numbers is, but on the order of petabytes of data. And so we talked through how do we can't just download all the data and do all the analysis. They don't have that much allocation or funding to get that much allocation. So we broke the problem down into pieces and say, what is the smallest piece we can download, even if we have to download the same piece over and over again? And can we run it in parallel and break it into the chunks? And I spent the entire morning talking about this exact problem. It's extremely realistic. The added troublesome with that is they're using a piece of software called ArcGIS. And it is really, I know some of you might argue, it is limited to Windows. There are ways you can try to run it on Linux. It just doesn't work in my experience. You might disagree with me, but ArcGIS doesn't work. So we had to change to something called QGIS, which does work. It's still hard to install, but we managed to get it. And then QGIS does their workflow. But then, honestly, because I was looking at their workflow and they're a grad student, I'm going to encourage this particular student to try to implement some of it in another programming language, either Python, MATLAB, or R, or maybe even C or C++, because I know the student's abilities and I think that that's reasonable, but also because the overhead associated with QGIS is quite large, and the calculations they're doing are sort of straightforward. And so I think if they write a little piece of code, we can significantly increase the throughput. But that is that I have to know, this is a student I'm working with personally, so I have to know their workflow personally, and I have to know that student's capabilities. And are they capable of doing it? Yes. Do they know how to right now? No, but it is reasonable for them to learn what they need to learn to get it to where they need to go. So that's just an example of, I am particularly working much closer to this because I'm working with them as a member of their committee, not as a HBC representative. But that's just an example of a real world problem. All right. So what other questions are there? I don't want any, we've got a few more slides, but we're getting close. What questions do you have about this whole thing? The CI's response is totally common. I'm even guilty, particularly during high onboarding times. I'm going to point you to this is what the HBC is documentation, because spending a half hour of every consulting hour explaining the same terms and constraints is a horrible waste of time that could have been used to actually talk about the research challenge. And that can be true, right? We only have a certain amount of time. And if you're onboarding every person and you're allowing every person to be an hour, and especially if you're a big HPC site, that can be extremely time consuming. What we have done, and everybody might have different solutions, and feel free to include those solutions in the chat. But when I do my consulting appointments, I schedule them. We have open office hours, and that's worked pretty well. It got kind of derailed for COVID, but we've got a little bit back on track. And I really liked having open office hours where anytime someone needed to do an onboarding interview, I would invite them to open office hours. And then if I had more than one person show up, I could actually onboard them together. That can be tricky, so you don't want too many people. But what's nice about that is you can often explain the same thing with more than one person in the room. And if you're good at that kind of communication, it can be very effective. It does take a little practice to get done. And if you get too many students, too many researchers, it can be a lot. But it helped me save my time. And then if they needed more time, then I would schedule them with a one-on-one. But that's just how I did it. Most of the time, I encourage grad students or postdocs who are being onboarded into their lab project, and they're that iPhone level user, right? We often get iPhone level users, and that's becoming more and more common. People are just less likely to use not only a command line, but even a computer. And so sometimes we have to onboard them quite a bit more. I actually had a user just recently who was using on demand, and they were doing everything from their phone. And it just blew my mind a little bit. They even had a keyboard that connected to their phone, and they just did everything from their phone. And I just thought that was kind of crazy. But they were able to do what they needed to. So it wasn't too crazy. I just thought it wouldn't be for me to do all that work. Um, um, be providing information before consulting time and ask for their research application so that at least they can Google level of knowledge ahead of meeting with them. I think that's not a bad approach. Not everybody will spend the time, but it can be worth it. Especially say, hey, if you want to get started early, here are a few resources. It can be a very effective way to before a scheduled meeting. Also, we've had success, and actually I'd forgotten I did this till just now. Someone's commented or reminded me. Another really neat technique is, hey, here's our meeting scheduled for next Tuesday. Here are some of the questions I might ask you. And you could ask some of those clarifying questions. And you say might, and you could say might ask you depending on the situation you're trying to solve. And what would be nice of that is that might help align expectations a little bit. And so know what they can come and what kind of questions you might ask. So one person says, we have very little face-to-face interactions. We have massive documentation and do a lot of email support. So you only have one day. And yeah, if you have lots of users, maybe you can't do face-to-face. I would say a lot of these can be done in email as well, right? You can solve the problem and maintain the relationship via email. It's just you can't do body language and you can't as easily solve emotion, but maybe you're limited by that anyways. And so I do a lot of my work via email, and I try whenever I can to solve the problems. Often it's like, hey, I'm going to need more information, or I will direct them to the website and I say, hey, this might help you. Otherwise, come talk to me again, those types of things. The idea, again, is not to say no, but to say yes if, and to try to build that relationship as much as possible. Okay. Other questions, or anybody want to say anything? We have a few minutes left. Yeah, so instead of having no face-to-face time, a different group says we have a lot of block office hours. We can route support tickets to there, come to office hours. And we actually have a whole team now of research facilitators, and they share office hours, or we try to. And what's nice about that is we can direct people there as a starting point. And we actually have 3 modes during office hours. I don't know if we're doing this as much. I'm not a part of the team as much, but at one point we would meet in person in a place near our offices, but we would also have chat available during office hours. And then during chat, we would often invite people to Zoom or video conferences. So we had 3 levels of communication that we could do during the office hours. And then a lot of people, and I say a lot, about 5 or 6 research facilitators. And what's nice about that is that as people come in, either via chat or via in person, we can divide the work up. And then, but other people can listen in sometimes and see what's being said, even if it's not directly related to their problem, it might be related. And then it creates a little bit of a community atmosphere that I really like about office hours. Now again, not everybody can do that, but if you focus on building a community and trying to help everybody answer questions, it can be quite effective. And there's a question you can answer with your favorite chat, but so Christopher asked, what ticketing systems do you like to use? I have a love-hate relationship with ticketing systems. I hate automated messages that are not designed to build the relationship. I much prefer personalized messages that are there to provide communication and not just automatically close the tickets when it's done. I hate measuring success by how many tickets you resolve. That's the wrong way to measure success. Um, Yep. And then another person, Nicholas, says instead of office hours, they use Microsoft Bookings. I have a bookings page. There's also a when to meet. I love it. So when I'm trying to schedule something with someone, I can send them to a website and I say, hey, just book a time with me, whatever works in your schedule. And I know that it will just appear on my calendar. You got to be a little careful with that because I've had people abuse that, but I just have a conversation with them and say, you know what, I need this for everybody. Anthony, it says, can you elaborate more? I don't know. I was trying to answer the question about calendar. The when you can book me. I'm sorry. Yeah, you can book me as a one that works well with Google calendars, and Microsoft Bookings works well with Outlook calendars. And it's just a website that it creates, and that you can pick a time and a place and describe what you want to work on. They're really quite nice. Team Dynamics, I guess that might be another one. Oh, that might be a ticketing system. ServiceNow, burn that to the ground, they said. Well, don't hold back. We use an open source one called Request Tracker. Although I don't say for or against anything, there are pros and cons to all of them. All right, Henry, I don't want to drag this out. What do we need to do next?
So if you have any questions, then your questions, which I think you dealt with that for the most part already. So if not, I think we can wrap up and move on to the lunch break, and then we will be back in an hour and a half for our next session, which will be facilitating cloud computing and explaining cloud pros and cons after the lunch break, about an hour and a half from now. And we're gonna leave um, the Zoom session live, so you can just stay logged in and go have a delightful lunch and come on back ready for the next session. And I'm gonna go ahead and stop the recording.